Okay, hello and welcome back. So today in class we looked at parallel and perpendicular lines. And before I get into supporting you with your homework, we're going to look at a general case. So when you're given a standard formula for a line, we're going to start favoring putting the constant at the far side. Okay, so we have the variable term side and the constant side. And that line can be considered to be looking like this. And it doesn't matter where the x and the y axes are, that's your line on the coordinate plane. So for a parallel line, well, let's just say for our argument's sake, there's the x and the y axis. This is called the reference, or the reference line if you set it to 0. So going in blue there, that will look like this, where they're parallel. Okay, and if we come along then and take a point, x1, y1, which is specified and known, we call it a given point, and we say we want a line parallel to this, going through this given point. What do? We say, well, it's going to maintain its reference component, its character, that's it gives it its slope. And we're going to translate it, where every point gets the same translation, according to the determination of this constant using the given point. Okay, and the parameters a. So we'll get ax1 plus by1. Okay, for example, find a line parallel to this through this. And the answer is simply 3x minus 7y is equal to 3 times 5 minus 7 times minus 2. 14 and 15 is 29. So you see 3x minus 7y equals 29. Okay. Now what if they gave us the line and wanted a parallel line and they gave it to us in slope-intercept format? Okay. They want a parallel line through 7, 2. Well, you just say y equals 5x plus a constant. You can call it k or you can just call it c, because c for constant. Okay, we're dealing with a whole new situation here. We can reuse the letter c. So y is 2. We'll probably end up with a fraction here. This is 35. No, we won't. And this is c. So c is negative 33. Okay, so you say that's your parallel line through that point where c has been determined to be negative 33. Okay, what if they give us an equation of a line and they want a perpendicular line through x1 given y1 given? Okay, well, here we did it from first principles. We got the slope, we worked out the perpendicular slope and put it all together, and we realized that all that's happening is b and a are swapping places, and so b and a, I'll just put them in yellow. Give me yellow. A and b are swapping places and a is switching sign, and then we determine the constant using the given point. So for a perpendicular line, we say that'll be bx, plus turns to minus, a goes in front of y, and you go ahead and you determine that. And holy cow, isn't that easy? Isn't that just simple? One line and you're done. So we're going to enjoy doing the homework. Just one more thing then, if we were given a line in slope-intercept format, and we wanted to go for a perpendicular line through a given x1, y1, then it doesn't matter that the x and the y term are split from each other. What's going to happen is the m is going to go in front of y. The 1 is going to go in front of x, but there's going to be a relative sign change. It doesn't matter whether you put that sign change here or here. The constant will look after the rest. Now we're going to get the constant by starting to sub. So we have, and this could be one you start learning off, but I don't think it's worth it, because I think you have my, bring back the x is equal to c. But of course that's my1 and x1, which are given. Okay. But I would not try to learn that off, because really it's nice to do the actual question. Okay. We're going to have plenty of examples as we go down the line. But let me do one now that I have the space here. So if y was equal to 7x minus 3, and you're looking for a perpendicular line through 2 minus 5, you would go, okay, pop the 7 in front of y, pop the positive 1 into as a minus 1 in front of x, and determine a constant. So 7 times y prime, y1, plus x1, because he's popping across, is your c. Negative 35 plus 2 is negative 33. Okay, and then you've got your answer. Your perpendicular line looks like this. Okay, give me perpendicular to this through this. Sure. 5 goes in front of x, plus turns to minus, 3 goes in front of y. We're beginning to determine 5 times negative 3 minus 3 times 4. We're nearly there. Negative 15, negative 12 is negative 27. 5x and negative 3y plus 27 equals to 0 if they insist on standard form with all the terms on one side that you give it to them. Okay, put it in a box. Don't mind getting out your various colors. In fact, I'm changing colors, but I suggest just use one color all the way through. There's really no need for colors when you've got algebra. Only maybe when you're learning it, you want to color code as you're trying to understand things. Okay, we'll push down along now to the questions. Just up one sheet for me, I think, or is it here? No, here. So you're doing the odd number questions now, right? We did that in class. So you're doing number 1. Find the slope of the line, this. Okay, so we'll call that standard form. Number in front of x over number in front of y, and change the sign if they're on the same side, which they are. So the slope of that line is minus 2. Now that's a trivial thing, and that's only a small part of the general operation. You normally won't be asked that in exam. Now find the equation of the line through 2, 4, which is parallel. Important word there is parallel, and it's through 2, 4. Remember now, if it's parallel, the reference variable part doesn't change, and substitution will get us just checking, was I recording? I didn't want to be talking to myself. 2 times 2 plus 4, that's worth 8. 2x plus y minus 8 equals 0. So it's only one liner there. You've question 3 for homework. What is the slope of the line perpendicular to it? To answer the final part, we don't need this, but the slope of this line is 2 over 3. X coefficient over y coefficient with the sign changed. Now find the equation of the line through 4, 1, which is perpendicular. So I'd like, in order to bring this up to the kind of scale that I write at, to write out the question again large. You're going to be writing very little, because we're going to give you, you're learning the quickest way of getting through the exam. So 3, because we're talking about perpendicular, you swap the numbers, you swap the coefficients 3x and 2y, and you swap the sign, and you determine using this, which again I might want to write big so I can see it more clearly. Okay, so you determine with 3 times 4 plus 2 times minus 1. Well, that little bit there is 10. And now I've played up the answer. If you ask, would it be okay if we left the 10 over there? Yeah, of course it would. Unless they say specifically give your answer in the form of ax plus by plus c, which they often do in an exam actually, equals 0. If they ask you to give it in that form and literally write it algebraically like that, which is the same as saying standard or implicit format, then fine. Then you know you have to bring it back. Otherwise, yeah, feel free to leave the 10 wherever you want. Leave the constant at either side. Okay, on to question 5. Parallel. So you're literally going to say, you know what, I'm happy with this plus a constant, provided I can figure out the constant using this provided I can determine the constant using this. So naught goes here is equal to 3 times minus 4. Okay, meaning this here must be 12. So my answer is y plus 3x, y equals, plus 12. Done. We did 6 in class, we're on to 7. Okay, so look, we read this earlier in class. We want to know this slope. Okay, we always want to show the y difference first because that's what goes on top of the formula. y2 minus y1, or x2 minus x1. So what is this? Well, I can count them. 1, 2, 3, 4, 5, 6. And if I'm more careful here, straightening that up, we have 1, 2, and 3. So we have a negative 6 over 3, which is a negative 2, but we don't write slopes like that because we know we're about to process it probably. And even if it's a parallel line, we still need to get this into the formula. Okay, so this is 2x, the minus turns to a plus, y is equal to a constant to be determined. Okay, we are now parallel. So we're just saying we know this is the slope. We know using that slope, we have this standard equation. We know now we can substitute 0, 5 on this line. Giving us, I'll put it here, 2 times nothing, plus 5. Okay, giving you your final answer for the line that you were asked about is that. Let's leave it there like that, which is very nice. Did 8 in class 9. 8.A. Best off trying to visualize it like this. And don't worry about your coordinates. Geometry did not respect direction. Remember geometry? Points, circles, lines, theorems. There was no direction. There was no grid superimposed on it. Well, you're often best off to relax your interpretation of the grid and not worry about what's positive and negative direction. I'll show you what I mean. So we just say, look, they've talked about a point, let's somehow visualize it like this. And the point B. So what I'm saying is I'm going to put them down like this, even though they may be absolutely rubbish, how I've written them relative to each other. Okay. Now in terms of the slope, we want this subtraction for the bottom always to be positive. So you want to head for, and let me put it another way actually. I know I'm into a long video now at this stage. Let me put it another way. You don't really have to know where they are relative to each other at all. What you want to focus on is picking the larger of these two numbers and subtracting. You say, so the bottom is 3 minus 1. Difference of x. So you want to make sure that's positive, just to avoid negative over negative. You want to recognize you subtracted 3, take away 1, so you're going to have to subtract in the same direction. 1 take away 7 is negative 6. That's got a slope of negative 2 over 1. find the midpoint. 3 and 1 is 4, half of that is 2. 1 and 7 is 8, half of that is 4. There's your midpoint. Now find the equation of the line which passes through 2, 4 and which is perpendicular to this. Okay, I should have read the question because I didn't have to go finding that at all. Well, let's soldier on. So perpendicular to this it doesn't matter what's there. Perpendicular, swap coefficients, swap signs, evaluate at 2, 4. Giving you 5x minus y equals 6. 10 take 4 is 6. And we'll leave it at that because nobody stipulated. That's the equation of a line just fine. Nobody may forced us into a particular format. Okay, using the grid in the given diagram to write down the slope of line A. So we're going to find a lattice point. That looks like 1. Okay, giving me a run of 3 and a rise of 1. Slope is 1/3. The intercept is 2. Y is equal to 1/3 of x plus 2. Write down the equation of A. Done. Write down the coordinates of the point P. Well, you're out 3, up 3. Now what you do there is you put capital P and you just leave the rest of it like that. And hence find the equation of the line through P perpendicular. Okay. Let's clear off that fraction there by multiplying across by 3 before we do anything else. 3y equals x. Yes, it's plus 6, but that doesn't matter. Okay. Call that 1. 1y, okay, drop it, equals minus 3x plus a constant. Subbing in 3, we get 3 equals minus 3 times 3. That's substituted technically. And we have c here. Bring the 9 back on the 3 is 12. C is 12. Okay. Now you have y equals minus 3x plus 12. Y plus 3x equals 12. And just because I have the answers here, I'm going to look down at number 11. That's correct. Okay, 3x on this side is the same as minus 3x on that side. Okay, so nice handy homework. Long enough video, obviously, but I'll post this to YouTube now and fire it into